Hello and welcome back. So in just a moment, we're going to be listening to Daniel Norman from Prisma, who's going to be talking to us about monitoring and observability of your GraphQL API with Fastify, Mercurius, and Prisma. But first, a word from NearForm. Okay, great. Thanks for that, NearForm. So next up, we've got Daniel Norman, who is going to be talking to us about monitoring and observability of your GraphQL API with Fastify, Mercurius, and Prisma. So a little bit about Daniel. Daniel is a software engineer with a broad experience across modern web and cloud environments. He's passionate about open source and modern development tooling and likes to bring ideas from different disciplines to software development. These days, Daniel is a developer advocate at Prisma and is focusing on next generation database access for Node.js and TypeScript. And outside the software world, Daniel's interested in woodworking and motorcycling. So over to you, Daniel.
Thank you for the introduction, Katie. So welcome. Katie, could you share my screen, please? So welcome to monitoring and observability for your GraphQL API with Fastify, Mercurius, and Prisma. Let me just start a timer here so that I can keep track of the time. Okay, let's get right in. So I want to start with a question. As a developer, you're often responsible for both developing features and ensuring that they run reliably. So in the context of a Node.js server, when do you alert? In other words, how do you know when things are not functioning well and require your intervention? And let me share a personal anecdote. So a couple of years ago, I was building a Node.js service that would allow you to subscribe to Ethereum contract events and get email notifications when events are emitted by a contract. The service's main persistence layer was Postgres, and it would source events from Ethereum and send email notifications with the SendGrid email API. One of the core requirements was to ensure that users would be notified as soon as possible when an event happens. I tried to keep the design minimal because I knew I was the one who had to operate it, and I don't really like waking up at night. Still, the service had quite a few potential failure modes, which were quite hard to predict in advance. For example, what happens if the service has trouble communicating with Postgres, the Ethereum node, or the SendGrid API? If the service fails to send email notifications, it wouldn't really have much value. And this is where monitoring came in. I introduced a monitoring and alerting tool named Prometheus and exposed metrics from the service such as HTTP requests and failure counters, HTTP request latency histograms so that I could see how long the service takes to serve user requests, database query counts, and failures. monitoring proved to be useful both during development and in production. I could get insight into the internal state and functioning of the service, which was useful when debugging. I could also see how the service was functioning in production under load and whether it was fulfilling its requirements. Most importantly, I could define alerts based on the metrics so that I could get alerted when manual intervention was necessary. The goal for the service was to work reliably, and monitoring helped achieve that. For example, after launch, I discovered a bug in the business logic that I'm not sure I would have detected had I not had the monitoring set up. So by monitoring the internals of the service, I created a valuable feedback loop, which helped ensure the reliability of the service. And the feedback loops will be a theme throughout this talk. In recent years, GraphQL has gained popularity as a robust and flexible way to build APIs. This raises the question, how can we apply this kind of feedback loop to ensure the reliability of a GraphQL API? I will do my best with this talk to answer this question. Today's talk will consist of 3 parts. In the first part, you'll learn about monitoring and observability and the role that they play in backend development. You'll get a chance to understand the what, the why, and the how of monitoring and observability. In the second part, we'll delve into GraphQL APIs with Prisma, and you'll learn how these two things fit together and how you can sort of approach monitoring and observability with GraphQL. And finally, in the last part, we'll do a live demo tying together all of these concepts. So let's get into it. Monitoring and observability. And we'll start with a definition. What is monitoring? So monitoring is the practice of collecting, processing, and visualizing real-time quantitative data about a system, for example, request and error counts, as I mentioned before, database query latency, and request latency. There are generally 2 kinds of monitoring approaches, black box and white box. And as the name suggests, black box monitoring is focused on externally visible behavior. For example, how long it takes for an API to serve a request. However, the problem with black box monitoring is that it doesn't reveal much about the internal operation of your application or your service. White box monitoring, on the other hand, is concerned with your application's internals and includes metrics exposed directly from your application code. Now, what is the difference between monitoring and observability? These 2 words come up and the line between them is often quite blurry. Now, because the 2 are closely related, I'll do my best to clarify the distinction between the 2. So monitoring requires you, generally speaking, to know what you care about before you know you care about it. Whereas observability allows you to understand your entire system and how it fits together, and then allows you to use that information to discover specifically what you should care about when it's important. Increasing observability provides highly granular insights into the behavior of the systems that you're working with, along with rich context, which is ideal for debugging purposes. For example, when you're trying to find the root cause of a problem during an incident, if it's due to a dependency somewhere deep in your stack, observability will typically surface this information, whereas monitoring will only surface it given that you monitor that specific component. Now, these 2 terms are quite ambiguous, and so for the purpose of this talk, I don't think it's necessary to really make a strong distinction between the 2. So let's get to the why. There are several reasons why monitoring and observability are important. But from a high level, monitoring helps you to ensure the reliable operation of your service. More concretely, the 3 reasons of why it's important are, the first one is alerting. When something goes wrong and requires your intervention, for example, a spike in HTTP requests returning 500, this is where monitoring comes in. Second is debugging. When your application fails, you don't want to be groping in the dark. Monitoring helps you find the root cause. Finally, analyzing long-term trends. Knowing your app's trends over time can help with scaling, capacity planning, and they can give you insight into how new changes when you're doing rapid development are affecting the internals and the performance of your application. For example, Suppose that you added a new search API endpoint that performs some search queries against the database. You might be interested in measuring the amount of time taken to serve such search requests, and also the duration of the database queries to serve those requests. If you notice that the search requests are pretty slow, it might lead you to investigate the query and perhaps discover that you're missing an index. So monitoring and observability can help you detect such anomalies and performance bottlenecks. Now, instrumentation is probably where a lot of this starts. Instrumentation is taking measurements from an application. That's all it is. And the following is a contrived example of an API endpoint, which takes some user input and then uses Prisma to persist that in a database. The endpoint has been instrumented with a counter which will increment every time it's called. It also has a label denoting the endpoint that was called, or the root, and the status code, which tells you whether the call was successful. In this case, and in most instrumentation implementations, the counter will be held in memory and then later fetched or pulled by a monitoring tool such as Prometheus via a special metrics endpoint. Prometheus is essentially a time series database that tracks these metrics over time. And with the metrics collected by Prometheus, you can then define alerts and then also connect Grafana and visualize these metrics. And here on the right-hand side is a Grafana diagram which visualizes the rate of requests by status. Now, by the way, these two don't map one-to-one because I was too lazy to set up Prometheus and Grafana for this. So you can see that in the code on the left, I use status_code, and then on the right, it's just status, success, or error. But you get sort of the idea. Now, if you look at the code again, you can see that instrumentation can add quite a bit of bloat to your code. And the good news is that in practice, you will likely instrument your application globally by relying on something like hooks. So for example, in Fastify, you can define an onRequest hook and then basically collect or increment the counters there so that you don't have to add this to every endpoint or root again. Even better is that, you have a lot of these libraries that will automatically instrument popular libraries. So Fastify, for example, has this Fastify metrics library, which will expose Prometheus metrics automatically for you, so you don't actually have to go ahead and add these counters and increment them. Now, there are three main observability data types. The first one is logs, which can be either structured or not. Historically speaking, I think that most logs weren't structured, and then once JSON sort of became a more popular format, it became more popular to use structured logging because you could run that and do a lot of interesting things with processing and push it to things like Kibana and Elasticsearch. Then we have metrics, and we already looked at counters. But we have counters, gauges, and histograms. So I already covered counters, but the idea with counters from a high level is that these are things that increase over time, like HTTP requests, database query calls. The second is gauges. Gauges are values that can go up and down over time, like CPU usage or memory consumption. And finally, histograms. And histograms are quite interesting because they allow measuring the distribution of latency in buckets from which you can derive the percentile performance. Now, if you're not familiar with percentile performance, I'll give an example. So, for example, if your average latency when you're serving 1,000 requests per second is 100 milliseconds, you still might have 1% of your requests which take upwards of 5 seconds. And so histograms, what they allow you to do is they allow you to see how most of your requests performing, like the 95% top performing requests or the 99. And finally, we have traces. And traces are essentially a breakdown of the actions in an individual request or transaction, and they consist of spans, and each one of these spans can contain multiple attributes or tags, whichever way whichever terminology you choose to use. traces are especially useful in a microservices architecture because a lot of requests in a microservices architecture might be served by multiple services. And so by having a trace which sort of has the information about how the request flowed through multiple services, you can really see where some of the issues might be arising. However, they're still extremely useful in the context of something like a GraphQL API that is served in a monolithic style from a single server. Now, it's worth noting that these three data types can be seen as sort of like an evolution. Logs are probably, they don't allow you to be, they're not processable the same way that metrics and traces are. And traces can probably be seen as the richest data type, which provides the most insight, although they don't always replace something like metrics when it comes to alerting. And as we'll see, it actually is possible to set up alerting based on traces. Now, what is a trace in reality? So a trace is a view into a request as it moves through a system. And here on the left, I actually have one raw sort of like JSON representation of a single span. And that span has a trace ID. And multiple spans, so multiple objects like this one on the left, basically represents the different parts of the lifecycle of a request, and then are pieced together to create this trace. So a span, as we have on the left, is a named timed operation that represents a piece of that workflow. And on the right-hand side, I have another span that belongs to the same trace ID. So it has, you can see, the same trace ID. And it also has this parent ID. And what's interesting is that, so this example here is essentially two raw spans that make up a trace for an HTTP request to a GraphQL API. And what's interesting is that through this parent ID, they essentially form a graph or a tree. Well, probably a graph is a better term for this. And so this allows them to be visualized. And one last thing is, if you look at the attributes, on the left we have more metadata about the HTTP request, and on the right we actually have the GraphQL execute step, so we can actually look at the query that was sent to the API. Now, this is what traces look like when they're visualized. This is a screenshot from Lightstep, which is a hosted service, and you can see I'm actually clicking through it, and there are three traces here. The top one is the HTTP request for the GraphQL API. This is sort of the parent of the whole trace, the parent span. And then the second one is the second one I moved to is the GraphQL resolve step. And finally, the Prisma query. And you can see that for the Prisma one, you can see the model name and the action, basically the query that was called. Now, each of these can have their own attributes, which really gives you all of that insight. And in the beginning, I mentioned Prometheus and showed an example. And it's worth noting that since then, the space of monitoring and observability has really evolved a lot. And this brings me to OpenTelemetry. So the OpenTelemetry standard is a new observability framework for cloud-native software and provides libraries, APIs, and SDKs for telemetry, observability, if you will. And overall, this is a great thing for the ecosystem, but the standard is pretty complex, and the documentation is still sort of playing catch up with the fast move in development of the standard and its implementation. But the good news are, first, the tracing API is stable as of February this year. The second thing is automatic instrumentation is available for many popular libraries, like even the Node.js HTTP sort of like module, GraphQL, and many popular libraries. And sort of speaking to the talk before that James gave about perf hooks. So, for example, the OpenTelemetry automatic HTTP instrumentation for Node.js actually relies on perf hooks that James spoke about. And the great thing is also that because it's sort of an open format, you can export these traces and view them both locally and on hosted platforms. So you have open source tools like Jaeger and Zipkin, and then hosted platforms like Dynatrace, New Relic, Lightstep, and I'm sure that there's a bunch more that I missed. So why is this great? Well, you can be on an airplane and you can still sort of trace your app locally while developing. Yeah, and we've covered all of this. So yeah, so the tracing API is reached 1.0 in February 2021. Now, this brings me back to this idea of feedback loops, which I mentioned was going to be a theme throughout this talk. Feedback loops are not a new idea. It's one of the cornerstones of agile development and applies to many stages of the software development lifecycle. The feedback loop could be defined as the process in which an action's effect circles back to the action and then used as feedback. For example, pushing a Git commit triggers a continuous integration pipeline which either passes or not, and if not, contains useful feedback about what failed. So feedback loops are everywhere in software development. As a developer, as a team, as a company, you're essentially engaging in an iterative process of creation through experimentation. And feedback is essential because that's how you verify your assumption. Now, you briefly saw the kind of feedback loop that monitoring and observability with the tracing view that I showed give you. And this leads us to the feedback loop that Prisma gives you and the second part of the talk. Prisma and GraphQL. So working with databases in Node.js is difficult. Prisma makes it easy to work with databases. Prisma is a next-generation ORM for Node.js and TypeScript and consists of three tools. Prisma Client, which is an auto-generated and type-safe database client. Prisma Migrate, which is a declarative data modeling and customizable migrations tool. And finally, Prisma Studio, a modern UI to view and edit your data. Currently, Prisma supports MySQL, Postgres, SQLite, Microsoft SQL is in preview, and MongoDB is in early access. The core benefits of Prisma are boosting productivity and increasing confidence. Working with database is one of the most challenging areas of application development. Data modeling, schema migrations, writing database queries are common tasks that application developers deal with every day. Prisma enables you to focus on implementing value-adding features rather than spending time plumbing together layers of the application by writing glue code. And these two pillars of productivity and confidence are really embedded into Prisma's workflows and API. Central to Prisma is the Prisma schema. This is a single source of truth for both your application models and your database schema. And from this Prisma schema, your database migrations, the SQL migrations, are actually generated. Now, you can either create this from scratch using VS Code. You get quite a lot of like auto-completion and sort of linting in VS Code. Or you can introspect an existing database in any of the supported databases, and Prisma will populate that Prisma schema for you. So how does it sort of boost productivity and increase confidence? First thing is it allows you to think in objects rather than SQL. Unlike most ORMs that map model classes to tables using this sort of active record pattern, Prisma maps queries to structural types. So really, Prisma just returns plain old JavaScript objects. It allows for working intuitively with relations, auto-completion and type safety for your database queries. I believe that there is no other Node.js database sort of access library that gives you this degree of type safety. And we're able to do that because of this single source of truth, the Prisma schema, that is. Declarative and human-readable database schema that we saw, that was the Prisma schema, and as I mentioned, the single source of truth. So this leads me into a GIF of Prisma in action, and here you can see that I am creating a user in my user table. And as you can see, we're getting already these squiggly lines, and this auto-completion, you can already see these are all the fields and their types as derived from the database. And so if I were to actually add a number instead of a string for first name, I would get a type error. And you will also see how when I'm adding a field that doesn't exist in the database, like not, I will get this squiggly line because it's invalid. So this is what I mean when I speak about type safety and the immediate feedback loop that you get thanks to type safety. Now, how does Prisma fit together with GraphQL? Well, GraphQL provides a powerful way for web and mobile apps to fetch data from an API. However, as a backend developer, you're still responsible for how your GraphQL server retrieves the requested data from the database. And typically you do that by implementing your GraphQL resolvers with some kind of like a library to an ORM. And this is where sort of Prisma comes in. You use Prisma in your resolvers to fetch data from your database. So that was how they fit together. And now I think we'll get into a live demo. And because, you know, live demos are a bit of a slippery slope, let's pray to the demo gods, or I'll try to at least be as calm as the Dalai Lama. So in this live demo, I want to show the source code of this application, this server, this GraphQL server that is built with Fastify, Mercurius, Nexus, and Prisma. We will look at the OpenTelemetry auto instrumentation. We'll make some GraphQL queries to the API and then view the traces and alerts in Lightstep. So let's get into it. And we'll go first to the code. So here I have my schema, my Prisma schema. I have 3 models here. I have the user model, post model, and comment model. And there's also relations between them. There's a one-to-many relation between user and posts, and also a one-to-many between post and comments. And also comments links back to the author that created that comment. Now, let's look at how the server is instantiated. This is a Fastify server that uses Mercurius, and there's a bunch of plugins. The first important plugin when it comes to sort of open telemetry and observability is this Open Telemetry plugin. This is a plugin that was created by AutoRelic. It's called Fastify Open Telemetry, and what it does is it essentially provides the instrumentation for traces for all your requests. And then we import this OpenTelemetry module. And I mentioned before that, you know, OpenTelemetry is still at this stage where it's like, it's just the API has been stabilized and it's still kind of messy to do all of the instrumentation. But once you get this working, it works like magic. And so really here I'm importing this, the sort of like the OpenTelemetry GraphQL instrumentation. So really it's just about instantiating that. And then there's this idea of exporters. I have a Lightstep exporter, which exports it to Lightstep, a hosted service. I also have a Jaeger exporter, which I use locally for development. And then I have just a Docker container with Jaeger so that I can view those traces. And finally, there's the console exporter, which will just export these traces, these raw traces to your console. This is really useful if you're just doing some very rudimentary debugging. Now let's look at the GraphQL schema. I'm using Nexus here. If you're not familiar with Nexus, Nexus is a code-first library for building GraphQL schemas. And the beautiful thing about it is that it has, you know, type safety at its core. And the other great thing is that Prisma is also contributing to this project. So what you can do is you can use the Nexus Prisma plugin in order to project the types from your database to GraphQL. So for example, as we saw, we had this ID field, name field, email, and posts, and in the Prisma schema. And now I'm sort of projecting that to the GraphQL types. And I'm doing that also for posts and comments. Now, it's also worth noting that assuming that, assuming that I had a password field or something like that that I would want to obscure, this is exactly where this would be done so that it's not exposed over your API. So it's important to think of a GraphQL API as an abstraction over your database, not a one-to-one mapping. Now, let's take a look at one query. So we have this all users query here, and this is the resolver for it. And what this Fastify OpenTelemetry plugin does is it injects through the request access to the root span, to the root trace, to the trace basically that is associated with this request. And what this allows me to do here is it allows me to actually create another child span for the database query, which I'm making here. So let's take a look at what this actually looks like in when I make a request. And so here on the left, I have okay, we'll open this in full screen. So this is the light step, and I know I'm running a bit over time, so I'll do this quickly. Let's look at the, so here I have the GraphQL playground. It's called alter, and I can make a call to this API, and here we go. We got a response. We can actually create another user. So I created another user and I got the response. And then if I go back to all users, I can then query that and we should be able to see, okay, so the API is functioning properly. Let's take a look back at Lightstep and see if we can actually look at these traces. So here I'm actually filtering these traces to only see sort of GraphQL API requests. And I believe that we have them here. So let's take a look at the first one that we had come in. And here we go. Okay, so it was a post request to the GraphQL. It took 47 milliseconds to process. Let's look at the GraphQL resolve step. So we had indeed this all users, and here we have the actual span for Prisma. For me, coming from working quite extensively with Prometheus, this is like magic. And the great thing is we can go back to the Explorer and look at the other query just so you can see. Oh, okay, we're back here. So one of the great things about yeah, so we can look at the last one, which I believe was at the, so it's requesting the trace, and then let's look at which query that was. Okay, that was also the users. The other thing I wanted to show is these streams that you can create in Lightstep. Now, every sort of like open tracing platform works slightly different, but here I can create essentially a stream of 500 errors and then trigger alerts based on this. So I have an alert set up here that says if 5% of the requests coming in is 500, I will actually get alert, and then you can configure that with PagerDuty through Slack or through a webhook integration. And so we're a bit over time, so I don't have time to show the alerting setup. But if you're interested, you can check out the source code for this app at the link that we will share in a moment. So on that note, I'd like to thank you again. I know we've covered a lot of ground here, but if you have any questions, feel free to reach out on Twitter. I'd be happy to answer questions. Thank you.
Thank you, Daniel. Really appreciate the talk. Lots of great information there. We are going to keep things moving along. Sorry for maybe this is unusual, but Katie had to run to the other session, so she is off. And if you want to join her and continue on with the sessions, there should be a little sidebar where you can see the agenda and join the next session. And don't forget, there's a workshop later today and a full day of workshops tomorrow. So yeah, thanks everybody, and see you in the next session. Cool.